Journey to Mars, exploring the red planet. The idea of traveling to Mars has been a dream of humanity for centuries, but it was only in the past few decades that we have started to turn it into reality. Since the first successful landing of a spacecraft on Mars by the Viking mission in 1976, our knowledge and experience of this mysterious planet have increased exponentially. Today, we have a fleet of robotic explorers orbiting, crawling, drilling, and sniffing the surface of Mars, generating a wealth of data and images that reveal a fascinating world of diversity and complexity. However, despite all the achievements and discoveries made so far, Mars remains largely unexplored and misunderstood. We have barely scratched the surface of its geology, atmosphere, water, and potential for life. To truly understand Mars, and to address some of the biggest questions in science and human curiosity, we need to send humans to the red planet. Only by being there, living and working on Mars, can we fully appreciate its challenges and opportunities, and push the boundaries of our technology, knowledge, and imagination. A human mission to Mars would not only be a scientific and engineering feat, but also an epic adventure and a cultural milestone. It would inspire and engage people around the world, igniting a new surge of innovation and creativity, and creating a sense of shared purpose and community. It would also require unprecedented collaboration among nations, as no single country or organization can achieve this goal alone. Together, we can build the necessary infrastructure, spacecraft, habitats, and support systems to enable humans to safely travel, land, and live on Mars. But how would such a mission look like? What challenges and risks would it entail? And what benefits and discoveries could it bring? Let's envision a possible scenario. The first human mission to Mars would probably involve a crew of 4 to 6 astronauts, selected and trained for at least 2 years to cope with the physical, psychological, and technical demands of space travel and planetary exploration. They would embark on a journey of about 6 months, using a spacecraft powered by advanced propulsion systems such as ion engines, nuclear reactors, or antimatter engines. During the voyage, they would face various health risks, such as radiation exposure, muscle and bone loss, and mental stress, which would require careful monitoring and treatment. They would also have to navigate through space debris, solar flares, and other hazards that could threaten their mission. Upon reaching Mars, the crew would enter into orbit around the planet, studying its geography and weather patterns, and preparing for the descent to the surface. They would use a lander or a rover to explore the local terrain, searching for signs of water, minerals, and other resources that could support future missions. They would also collect samples of rocks, soil, and atmosphere, and conduct experiments to test for the presence of life or its precursors. They would communicate with Earth and other space agencies and scientists, transmitting their data and receiving instructions and feedback. Living on Mars would be an entirely different experience than living on Earth or in space. The Martian environment is harsh and extreme, with a thin atmosphere, high radiation, low gravity, and temperature swings of more than 100 degrees Celsius. The crew would have to adapt to these conditions, using a combination of technology and biology. They would wear spacesuits or live in pressurized habitats, providing them with air, water, food, and other essentials. They would use 3D printers or other manufacturing techniques to produce spare parts, tools, and equipment.